What mathematical relationship could be so cool that Archimedes, one of the greatest mathematicians of ancient Greece, wanted it on his tombstone? Well, it involves a sphere, like the shape behind me, a cylinder, and a cone. So, first of all, let me explain that if you took this sphere and you thought about the largest circular cross-section you could make from this sphere, then that circle is exactly the same diameter, same size as the base of this cone. And it's the same as the base of this cylinder. So the cone, the cylinder, and the sphere, if I had three hands, this would be easier, all have exactly that same circle in diameter. Also, again, if I had three hands, this would be easier to do. Also, these all have the same height. Okay? So, in other words, this is the largest sphere that could be inscribed inside of this cylinder. The top and the bottom would touch perfectly, and the width would fill it perfectly. Okay, now the question is, what is the relationship between the volumes of these three objects? And I'm going to give you a minute to make some predictions. What do you think will be the relationship between these? Again, you will be more invested in this if you've made a prediction or a bet. Bets are nice too, but I shouldn't encourage gambling. But there is some kind of a connection here. Now, you might be noticing that the cylinder is probably the big one, and then the sphere and the cone are smaller. So what I'm going to do right now is going to put my valuable laptop and computer equipment in danger here, because I'm going to get out some water, and we're going to pour some water inside of this sphere. And then we're going to pour that water into this cylinder, and we're going to see how much of it seems to be filled up. And then we'll do some more water pouring to investigate this relationship further. Hopefully I have enough water left in here, or we'll be reshooting this video. Okay, so I am hopefully, oh geez, some spilled out, okay. None got on the laptop, we're good, okay. This is a, yeah, challenging pouring activity. Whoa, okay, well, it's definitely full, okay. And we are going to pour into the cylinder. So sphere into cylinder. Okay, table's wet, but the laptop is not. So, so far so good, question mark? Okay. Hey, so it didn't fill it as we would have predicted, but how much is left? What proportion of this do you think is full right now? Well, I definitely don't dare to pour another one of these in here, because then I will be destroying some laptop equipment here. So what could I pour? Well, I do actually have a half of this sphere available of the exact same size. Do you think that's going to do it? Let's try it out. So here is half of the sphere. And the nice thing with that one is I can, by the way, it would be called a hemisphere. You might have heard that when you're thinking about like the globe, like a hemisphere. Hey, we even got a little bit of ice in here, right? This is my actual water bottle I've been drinking out of today, by the way. Not just a random prop for the video. So it is ice water. And hey, look at that. We didn't destroy anything, and it filled it perfectly. So what does that mean? What does that mean? A sphere and a hemisphere filled the cylinder perfectly. Interesting. Now, I've got some water stuck in the cylinder, and I don't really know what to do with it. We're gonna, I think I have something I can dump it into over here. Okay. We're gonna move along. So what other relationships can we investigate here? I said there was some connection between the cone and what was going on here. So I wonder how many times it would take the cone to fill up the cylinder. Now, if you watched my video about pyramids and cubes, I actually challenged you to think about that as an extension to that problem. So here is now your chance to find out. Again, make a prediction. How many cones is it going to take to fill up the cylinder? How many cones to fill up the cylinder? Hopefully I have enough water or I'll be reshooting this video. All right, there's one. Again, you could revise your prediction. Okay. There's two. A few drips got out, but the laptop's okay. Where are we at now on the cylinder? Trying to get you a good shot of that. If my camera sees my eyes, it focuses on my eyes. But if I block my eyes, it'll focus on something else. Okay. And then we will pour again. And it looks like we do have enough water left in the trusty water bottle. And where are we at? It is perfectly filled to the exact top. So how many cones did it take to fill up the cylinder? Now, I'm gonna carefully put that away from my laptop. Okay. Disposed of safely. So, we now know that 3 cones fill up the cylinder, and we knew that 1.5 spheres filled up the cylinder. So this time my extension question for you is, what is the relationship between... That one almost got the laptop. I didn't realize there was still a little water left in there. Okay. Oh boy. Ooh, some is on the laptop, but we're still recording, so it seems like I think we're good. Okay. Laptop didn't explode into electrical fire or anything. Okay. Lost my train of thought. So challenge extension question here. What is the relationship between the volume of the cone and the volume of the sphere? How many cones would it take to fill the sphere? And maybe you could even express a mathematical formula between the volumes of the 3 objects. And you can always put your answers to any of these questions down in the comment sections below. And I hope you guys have an excellent day.